international journal, a special issue about entropy and the second law of thermodynamics, and then people are writing papers for that journal, and I'm basically sending it for review and making decisions what's to be published, what's not. And in one manuscript, there was some reference to your paper that you published about.
I just published a 120-page article on the overlap of information theory and thermodynamics.
So information is not. What was the title? Information is not
equal thermodynamics, not equal information theory.
Right. And then I was reading it, and I was emailing to him saying that I happen to agree with his opinion, because there is a group of people who like to basically do analysis of thermodynamics through statistical methods, and then they forget about the physics. They are so into the statistics and say there is no need even to think about energy or entropy, it's just information theory.
The gist of what he's saying here is that after you go on and you write papers, don't try to mix up engineering with information theory. It's just going to be a waste of time. It's called the Shannon bandwagon.
Yeah. So basically, that's how we started, and I learned that he was doing guest lectures at UIC in Professor Mansouri's class, who was my professor of thermodynamics when I was graduate student there. And then I contacted Professor Mansouri, and he said, yes, I know Libb. He presented, I think, three times.
Yeah. Three times I presented at UIC. This will be my fourth lecture. And in June, I'm doing a talk at the Count of Physics and Count of Sociophysics conference in Romania. The other thing is, in the process of following up, trails of people who do something in science, actually it all coming one after another. I was listening to a lecture of a physics professor from MIT, which is taped and on a YouTube. His last lecture, when he was 75, full auditorium at MIT, he was signing up his own book. And he was then doing some demonstration. I don't know whether you've seen that lecture. What was his name? Professor Lewin?
I don't
Physics guy who swings the ball?
Right.
Yeah.
Did you see it in Italian?
Yeah, he wrote a book called The Love of Physics.
Right.
Like
so basically, Libb Thims is encyclopedia in a human. He runs actually a human thermodynamics encyclopedia on the web. Very special person. And then that physics professor was doing very interesting, simple demonstration of physics. And then at the end, they were asking him how come he happens to do that in his life. And he said, I consider myself to be eccentric all my life. And we are all eccentric in our own rights. And eccentric means special. And that might be Tim. I don't know you that well yet.
Yeah, that's a good word for
yeah. So basically, he will be now talking, and I just wanted to introduce it a little, as little as I know. And his stuff is all on the web, right?
That's right.
So basically,
go to vuht.info.
I'll let you now go on and do whatever you want, and you have 40 minutes of your time, plus who wants to stay during the break will be available. And welcome to NIU, and we'll talk after the lecture about thermodynamics.
Thanks for everybody who came today. My goal will be to do a real fast-paced lecture, because I'm going to put it on YouTube. It's hopefully be up by the end of the tomorrow. And I'm going to talk for 30 minutes. There's about 10 online lecture pages. And hopefully I'll have time to do the famous ball and ring experiment, which was done at Leiden University back in the 18th century with true crowds of 500 people. Because people in the 17th century couldn't figure out how you could, they didn't know what heat was. They thought heat was matter, or if it was a particle, or if it was weightless. They couldn't figure out how you could put the copper ball through the ring, heat it up, and then it wouldn't go through. And crowds of 500 people would come to watch this. Professor Boerhaave, it's called Boerhaave's law, is the principle of thermal expansion. And then after the lecture, I'll have 10 minutes for questions.
Sorry for the interruption. Libb Thims was nominated to get a Nobel Prize, but he didn't win it yet.
The book you have right here was, I wrote it in 2007. It's the first textbook on human chemistry. And the Russian physical chemist Georgi Gladyshev with his wife flew out from Moscow and told me that they sent the book into the Nobel Prize Committee. And he's been working on free energy theory for 30 years. So it's a real underground subject. Everybody studied Cengel's textbook, is that right? You know, we're going to hear maybe 2 or 3, we'll touch on some of the examples in there. You might see a cartoon like entropy applies to disorder or entropy applies to war. But we're going to go beyond that. There's actually over 500 people that have gone deeper into that problem, and I've written biographies on all of them. So let's take a look at this. And these quotes here, we're talking about, I'm not against the hasty marriages where a mutual flame is fanned by inadequate income, as well by Will Durant. And then the key word there is flame. The second word there is income, which is a correlation to work. And the second word we're talking about how people have in France, certain groups had hot faith, and certain other groups, for example, Diderot wrote the first encyclopedia, and he had cold hostility. So the question is, how many people think this is all a metaphor, or how many people think that there's any connection to thermodynamics? Just a quick show of hands. Who thinks this is just metaphor? Anybody thinks there's connection to this thermodynamics? Okay, so that's what we're going to talk about in the lecture. Will Durant's a famous American philosopher. He wrote something like 12 volumes of his philosophy. So, first, just to take a look at this one here. Here's an example of one thing we're going to talk about is the definition of human as a 26-element molecule. And my definition just made it into the thermodynamics textbooks just in 2011, which is a new way of thinking about humans as a reactive molecule made of 26 atoms. Now, when you're in this frame of mind, you want to get out. You're going to have to relearn your belief system here. So, 2 examples here is flame started with light, and both these are started by the action of photons. The photons are just concentrated in the first example, magnifying glass burning lead. In the second example, sociologists have found that 2/3 of people believe in love at first sight, 20% of people fall in love at first sight and marry that person. So a sight is 2 human molecules in a certain state of existence, which you can quantify in terms of free energy, and sunlight, visuals triggers the reaction. And the second part here, Robert Sterner and James Elser were actually technically the first persons that calculated the molecular formula for a human. So this is a new way you want to think about humans. In 2002, the stoichiometric approach considers whole organisms as if they were abstract molecules, thought of as complex involved chemical substances that interact with each other in the abiotic world that resembles a complex chemical reaction. The calculated formula in 2000 on the spreadsheet. I calculated mine in 2002 on the spreadsheet, but I didn't publish till it wasn't on the internet until 2005. So you want to think about human as every human represents the coming together of atoms and proportions that are not constant, at least bound and obeying some rules. So just to get our feet wet here, we're going to look at free energy landscapes. Free energy landscapes are what are called the potential energy surfaces. And they were developed, the first one was done with the reaction of hydrogen and moving in and out of the nuclei. This was done with Michael Lang and Henry Aaron. And soon, into the 1880s, this got scaled up into what are called energy landscapes, where they were applied to protein thermodynamics. Probably see them in your book. You plot something like free energy versus extensive reaction. This is where it originated. So into the 90s, this started getting mixed up with survival of the fittest theories. That fitness, Sewell Wright, American geneticist, he argued that survival of the fittest can be understood in terms of fitness landscapes, or genes, something along those lines. But it got convoluted in terms of free energy in the 90s, where now fitness is analogous to free energy, the minimum of which determines the configuration of the system. So an example from 2001 here is Adrian Delaney. She's another associate of mine. He did some of the first free energy work on, this is his free energy diagram of evolution, where you have free energy mixed up with Darwinian evolution, mixed up with corrosion and anticipated structure theory. And without going into too much detail here, when you have a flame But when a flame ignites, when you take a magnifying glass, and the leaf is at a point somewhere like right here on the free energy diagram. This is free energy versus time of extensive reaction. So you take the magnifying glass and you heat the leaf. It goes over the activation energy area. Leaf is a hydrocarbon structure, atomic geometry. It goes into a stable configuration. So the same here, these are American computational chemist David Wang's free energy diagrams for two people, for people in college forming relationships. And it was male, female, and so let's say two people, light triggers, love at first sight, the couple forms into a stable relationship here.
If I may interrupt very quickly, we are mechanical engineering profession, and that's actually the last chapter in our textbook that we are not even covering in Thermodynamics 1. It's about chemical reactions and thermodynamics, but let's expand your basically mind to grasp as much as you can. Unfortunately, we have also two Thermodynamics 1 and 2, but they could read afterwards.
Yeah, that's one of the issues why this isn't being taught right now in schools, is because subjects have become so diversified that you can spend 20 years in economics and 20 years in, say, sociology, 20 years in mechanical engineering, but it's difficult to grasp the big picture. Okay, so now we're over here. How many people have heard the truth that every truth goes through 3 stages? First is ridiculed, second is violently attacked, second is taken as self-evident. Anybody heard that quote before? Well, the person that quote is based on is called German poly-intellect Johann Goethe. I'm going to take a quick look at that. Because he's the first founder of what you have in your hand, in chemistry. So, how many people have heard of Arthur Schopenhauer? Anybody? He's a famous German philosopher. So truth passes through 3 stages. So in 1787, Goethe is actually Charles Darwin's evolution of species. He cites 3 people as having been precursors to his own work. And the first of these is Goethe. And he discovered human electrochemical in 1784 by studying skulls. Before that, it was thought that humans weren't the lineage between, there was no connection between animals and humans. And in 1796, he started studying physical chemistry and understood how you could scale up chemical reactions where A and B are bonded in a chemical reaction bonding bracket, whether it's chemical species. And if you introduce a 3rd species which has more affinity for A than B does for B has for A, it will displace B and A will form a bond with C. So we scale this up to human chemical reaction theory. And in 1890, published the 36-volume chapter on that, where each person is chemical species. People such as Milivoje come in, which was like a catalyst. And there's an Italian-French version of the movie where I look at that. So just so people don't know, has anybody heard of Goethe before today? Okay, we've got 3 people. I didn't know who he was until 2006. This was actually searching through literature for 11 years trying to figure out who exactly started this theory. But for those who don't know, he's consistently ranked at the person who invented the IQ scale is Turner. Catherine Cox's graduate student ranked the 300 greatest geniuses of all time. He ranked first. In 94, Tony Buzan had a totally different ranking scale of the top 100 geniuses of all time. He ranked second behind Shakespeare. So this is the group, the average IQ of all these. And he published 142 volumes, some of which are shown here. And in terms of world libraries, the only person who has more books held by world libraries is Shakespeare. He published in almost every field. And of all of his books, he was confronted in 3 after he published his 1809 theory by one who said, "I cannot approve of your elective affinities. It is a moral book." For which he paused for a few minutes and he said, "I'm sorry to feel that way, for it is my best book." That's what we're going to talk about today. All these books. Smartest person ever. This is his best book with selective affinities up there. And he goes on to say that the principle illustrated in the book is true and not moral. So the principle he talked about in those days was called affinity. Now after 1882, affinity was proved to be, by German physicists, independents, to be the measure of free energy. There's a whole undergone derivation process behind that. So the principles we're going to talk about today are free energy, but in his day it was called chemical affinity, but the 2 are connected by what's called the chemical free energy equation. So So here, like I told you, Charles Darwin cited 3 people as pioneers of evolution. P. Jeffrey, his grandfather Erasmus Darwin, and Goethe. And Goethe, first in 1907, figured out, he called evolution metamorphosis. So that goes back to the Greeks and Ovid's poem. But Goethe figured out how form change occurs in plants in 1790. He published Metamorphosis of Plants. Then he published Metamorphosis of Animals in 1806. Then he connected it, human metamorphosis all the way down to the chemical level. This is the 3-part treatise called Metamorphology. And this being Darwin, the issue with Darwin's problem is that evolution stops with the warm pond model, where a lightning bolt came down and struck warm pond, and that triggered evolution. But in Goethe's model, the scale goes, the theory he has goes all the way down to the hydrogen atom, which the conclusion of which is that everyone in the room is the ancestor of the hydrogen atom from 13.7 billion years ago. And this in terms of chemical thinking. So the problem here, this guy here, Hilaire, he said, well, the problem with Darwin's theory is it is quite certain that at one moment there was life that did not exist and on the planet, and it's quite certain that it appeared that one moment when life did exist. The passage between these 2 states, non-life and life, is what's called the great problem of natural philosophy. Now, we bring this up here because when you apply free energy to humanities, you have to do what's called de-anthropomorphize your language. Because life is not a term that's found in chemistry textbook or physics or thermodynamics. So you have to reframe your belief system and use terms that are found in thermodynamics. Or else you'll be discussing what's called metaphysics. So here's an example of the attack. David told him that it was a truly horrible work. This is the second stage of, or the first stage of the 3 stages of truth. He said it's childish nonsense and fooling around. Supposedly a quote written by the smartest guy who's ever existed. It's childish nonsense. So his first student was Schopenhauer, who consulted with Goethe when he was 18. He went on to build the world, wrote 2-volume book, The World is Built, The Will to Power Theory, if anyone knows that, all based on Goethe's theory. So then, most people don't know that Nietzsche became a student of Schopenhauer, which is based on Goethe's chemical theory. Max Weber was reading the 1809 book Elective Affinities as a student when he was 14 years old, behind his school books in his classroom. And he went on to found sociology. He's now known as the last universal genius of sociology, social science. I know that's one of the last persons in Europe. Freud also, most people don't know, he wrote 26 volumes. In 1985, he based his work on Schopenhauer, but instead of affinity, he did it on free energy. He wrote a 95 unpublished thing called Project for Scientific Sociology, which based psychology on free energy, which is called bound energy. Most people don't know that Freud's whole period is two-dimensional theory is called basic thermodynamics. And the first, just to show you, the first guy who published on this work, James Froud, he did the first English translation of Goethe's Elective Affinities, the founder of this book, and he had to do so anonymously because after he read Goethe's Affinities, he lost his faith, and he wrote this book called Nemesis of Faith. His books were publicly burned. He lost his post at Oxford. And then all of the publications of Elective Affinities thereafter were anonymous until 1902 when found he published these things. And so the book we read is spoken out for 50 years as Goethe's most dangerous work. So today, how many people have heard of water? People are friends mixed like water and wine. People are enemies separated like oil and water. That's from Empedocles. The Greek philosopher 2,000 years ago. And Goethe, when he wrote this book, he did the oil and wine argument in one of his chapters. He cites Empedocles. Empedocles is probably the leading scholar in the world in quantum physics, thermodynamics and economics, and thermodynamics and sociology. He's working on a book called Thermodynamics of the Human Bond, or Chemistry of the Human Bond. He cites Goethe and Empedocles. Today we're going to cite all 3 of them. What we're going to notice here is the learning curve is decreasing, going from the 2009 book of Libb Thims. So now, try to speed things up here. These are just a few simple look here. These 3 stages of this is a chemical engineer. He says you cannot, this is on a chapter on thermodynamics of chemical reaction. He says the whole thing was not any scientific knowledge. Serge Galen's been running a socio-physics department in France. And he's, for 20 years, he's been treating humans like atoms, which is technically supposed to be new ways to do humans as molecules, not as atoms. So physics can still do this. But he says for 15 years, he's been ridiculed. He said his subjects have been condemned. That's the stage 2 of truth. This is Ted Erickson, chemical engineer. He was one of the first reviewers of my textbook. He says you can't argue with this. Now this person, on the other hand, Peggy Sarah, he says that she's a psychologist who wrote a book in 2009. But her, she took the second on, developed a discussion of energy theory of thermodynamics, which is that entropy has something to do evolutionary when people get depressed in the states of non-movement. But her thing is mixed up with spirituality. So she says, anyone who's using what we're teaching today, I just finished teaching, mentored my first PhD student on the internet. She says, well, if anybody's doing PhDs, their advisors should shop. So this is a violent opposition of your stage 2. Here's one thing I'm trying to do is one of the reasons I'm going around is I'm trying to find a department that teaches this stuff in America. And slowly starting to try to speed along here. So here's some of the main books this is the main lecture page. Anyone when you're done, you can all go back and go online if you want questions. Post in these threads down there. Just go to uht.info and post questions about this. So here's the equation that connects, this is proving it. Affinity is now equals to negative the partial Gibbs free energy for extended reaction, which is either time or measure of reaction products, isothermal, isothermal reactions. So all of society is, temperature is constant, pressure is 1 atmosphere. It's going to be about 40 degrees today. So this is out of all the equations I learned in school, this is the main equation that explains human existence. So here's Goethe's book, 1809. The second book on human chemistry was chemical engineer Fairburn. This guy, Thomas Wallace, published the second book on human chemicals, written in consultation with another Harvard chemist called Charles Darwin. He's the grandson of Charles Darwin. The subject we're talking about today is thermodynamics. In this book, we define thermodynamics as the statistical thermodynamic study of human molecules. So you have to define your system, and people are defined as molecules. Ecological stoichiometry was the first published form of the molecule. And in 2011, my formula is now defined as the standard definition of human. Look at that. So these are the first 2 books I've written. Jürgen Hempy's book, Georgi Gladyshev, was the greatest scholar behind me. Table of contents. We looked at truth. We're going to, the main point of the lecture is we're going to get through this fast enough. 1809 book published this year. There's a movie on it right now. 1906, Italian, French, and much of it. Campbell proves that affinity factors was measured in terms of affinities will only be active when the system shows a decrease in affinity over time. This is the principle that was used when you try to understand your existence and experience. And the basis of this is giving you unlimited validity of the second law of thermodynamics. So here's your molecular formula. This is the 26-element version. And Stirner and Elser is a 22-element version. And this is starting to make the way around the ecology textbooks. Just quickly, these are all last universal geniuses. John von Neumann, all 4 of these guys have 3 or more citations as being the last universal geniuses. And Neumann here says that free energy is, in 1832, his thermodynamic variable table. He says energy is value, entropy is liberty, and free energy is cash value in terms of economics. Now this could be wrong, could be right. There's these are called thermodynamic variable tables. And the issue with human thermodynamics is it's difficult to correlate these numbers, these thermodynamic values which you have in the textbook, into humanities values. And Christopher Rotter here he published on human chemical thermodynamics. He did some of the homework problems where we could sign. And this guy, both these guys this guy was cited with IQ 225. Both these guys were This guy's one of the 10 youngest PhDs in the world right now. And he did all this independently to chemical thermodynamics theory. He wrote some. Keep moving. Here's the form that Goethe did. Main chapter 4 of the video out there is calcium carbonate with sulfuric reactions compared with the reaction that with Charlotte when the captain comes to visit his friend is considered sulfuric acid. He breaks up the union. These guys haven't seen each other for 20 years and they start hanging out in the state. And the whole chapter skips through 36 of the reactions. Now these are the atoms are comprised of hydrogen, 26 atoms up to iodine. Just a floating magnet experiment is the way to start thinking about this, instead of survival of the fittest and chemical thermodynamic way to think about this is the Earth system. 4.5 years ago, a member of hypothesis discloses that the Earth was a volume of gas with 92 elements. It started to spin, the sun contracted, and started releasing heat. Now, every time the sun heats the surface of the Earth, photons go in. Photons cause the atoms to jump up in orbital structure. And when the electron is up in orbital structure, the atoms become unstable and move in new geometries. And these are negatively charged needles floating on cork over which a large hovering magnet is floating. And J.J. Thomson used this to divide the first structure of the atom. But you can think of this as the way the atoms continually form into layers. Every time you photons, 1,000 photons fall on a pinhead each center. And the photons, ever since 4.5 billion years ago, the atoms consider progressive larger formations. At a certain point, molecules become animated, which is what we are, animated reactive molecules. So here's an example of red 3-element molecule, C20H28O. It bends in the presence of light, or it straightens, and when light's removed, it contracts back. So we're larger versions of these. There's Thomas Wallace, he's a physical chemist. He did some of the first energy theory. Just to show, you want to understand whether or not a process takes place physically, chemically, or in society. You have to be able to measure enthalpy and entropy change determines whether that process will take place. And this is an example of this reaction theory. The primitive stage, fetal stage, the state stage, the imperial stage, and the back to the fetal stage. This is a big history way of looking at things. So here's me back in University of Michigan's Chemical Engineering student. So one of these classes I was sitting there, I wanted to know how do you go apply this to predict whether, say, Jack wants to marry Jill or Jack wants to marry Jane. And you don't know which way Jack should go about it. How do you use this spontaneity rule here, which signifies if free energy shows a decrease, then that reaction is more favorable. So I never raised my hand in class. One of these classes here is where I came across this puzzle. So I spent 6 years working on the puzzle, and then in 2005 I started going out publishing work on the internet, and I started reading about everybody who's ever written on this. And so now I've written 2-volume textbook, 1 book, and a 6-volume encyclopedia on all this. And the encyclopedia is online, but it's third degree. So it turns out that the year before Goethe wrote this, he had the same puzzle as I did. When you wrote a book called The Renouncers, in which the hero of the story was simultaneously loved 4 women, and you wanted to know what was the best way to go about this morally. And so he turned to physical chemistry and wrote this book. And here is chemical engineer Alex Grossman. He's a university rector. These are presidents of universities in Italy. He's announcing that my human chemistry, Goethe-based human chemistry, will now be included in it's a new scientific field. It should be included in the engineering curriculum, which is one of the things I'm pushing for. And here's the Journal of Thermodynamics. I just found it in 2000. Found this in 2005, but just last year as a former review board to draw professors at different universities. So James Chen here is working on a mixture of economics, business, and thermodynamics theories in Canada. And these are all these other guys. all moving forward. So one thing that I'm trying to do in America is get these subjects established. If I would have been told that Leon Arseny was teaching this subject for 6 years at the University of Geneva when I was an engineering student, based on Clausius inequality, based on economic sociology, and based on Clausius inequality. But you're not taught that anymore because it feels to become so diverse that these things, this is difficult for one person to deal with. The subject has become atrophied. In 1928, the leading school in sociology, Peter and Sorkin founded Harvard Sociology Department. The leading school was social mechanics, mechanistic school of social thermodynamics. This was the leading branch of sociology in 1928 out of 10. But now this isn't important anymore because you can't study chemical engineer and be a sociologist at the same time because there's not enough time. And who wrote that? John Stewart ran for 5 years, ran Harvard Social Physics at Princeton. So this is what I'm trying to bring about. And right now, I'm trying to get the thing introduced to Berkeley. Because Berkeley is the biggest chemical thermodynamics department in the world. But there's a lot of resistance to it. And here's this is student reactions from the last lecture I gave. The first lecture I gave at the UIC. The professor, Ali Mansouri, is Professor Kostic's professor. He asked all the students to write a review of the lecture I wrote. There's not speech, but this is one of the most brings out the issue to the front. She says, well, I don't believe thermodynamics. It can only apply to man-made things, engines, combustion. She says it can't explain things such as mind and soul. This is taboo word in engineering and physics in general. And again, this is what you have to do: reverse de-anthropomorphize yourself. This is a word found in chemistry, physics, and engineering. But this is the issue. This is where the conflict lies. Now, Ali Mansouri, he wrote the first book on human thermodynamics. He was the 75th Prime Minister of Iran. He says in his books, I will try to discuss morality from the point of thermodynamics, but it is difficult. Nonetheless, it's better to attempt than not to attempt. That's what we're trying to attempt today. It's a difficult subject. So Goethe did the same thing. He wrote his first PhD in law. Dissertation was on legislator Power magistrate when he was 21, the German culture religion. He says, Jesus Christ is not the author of Christianity. It is subject comprised of a wise number of men. So when instead of he went on for 40 years later, instead of turning to the Bible, he says you can now turn to the physical chemistry textbook and the chemical thermodynamics textbook in modern terms. Moral symbols in the natural sciences were the elective affinities discovered and used by the great Bergman, which is this textbook. This is the first published in 1775. And this is where Goethe based his novel on this textbook. And in his last year, his second year last year for the system, he said, I found no faith in which I can ally myself without reservation except for this. And here's the clip of this guy that found the book he read. After he gets his dissertation, of course, gets rejected because it goes against orthodox. So here's a quick 10-second clip.
Только факт.
This guy was kind of a rebel. He didn't want to conform to standards of society. So you have to come to grips with your belief system. So here's American Academy of Sciences belief in the existence of God and mortality. There's only 7% of the American scientists believe in God, 8% believe in mortality. So this is the old theory. What we're talking about today is the new theory. We just upgrade to all of that. Here's the percent belief in God by scientists over the years. In the 1910, this is presently, this American Academy of Sciences. Right now, about 5% of scientists believe in God. But the world religions are completely different. And when you do human thermodynamics, you're going to have to dig into this. This is the world's belief systems right here, all divided up. These are groups which is difficult to track are actually based on Egyptian religion. Ra is the sun. This translates as father. Ra is the sun. These are all so all of these religions, 72% are all derived their belief system on the birth and death cycle of the sun. So when the point where I'm bringing this up here is because when down the road you will try to understand the origin of life in terms of thermodynamics, you have to understand where that life does not come from science. It comes from the Egyptian theory. 72% of the belief systems that we're all taught when we're children. So, for example, if I asked you who is the founder of evolution theory, everyone says Darwin. What about relativity? Theory of relativity, everyone says Einstein. But if I ask you who is the founder of the theory of life, anybody have a name for me? So, what we're doing here is upgrading this in terms of thermodynamics. So you're going to have a lot of conflict if you try to hold on to this concept of life and death in terms of thermodynamics. Here's America's even worse. America, 62% believe in God, 29% believe in spirit or life force, only 2% of people don't believe in any of this. Which, as engineers, we're probably more in this group. But in Romania, where I'm going in 2 months, look at it's almost 90% of people believe in God or spirit or life force, which is puzzling why they're having a common physics socioeconomics conference. Then you can go on here to read other student reactions. Most of them are all, I didn't know you could apply thermodynamics to politics, sociology, business, etc. This is from my first lecture in 2010. And here you can see how thermodynamics applies to marketing. Here's Dan Colby. He's the Google marketing director in Europe. He applies thermodynamics and physics to marketing theory. So if some of you are going to go into marketing after that, this is where you want to go. Here's the common physics conference I'm going to. This guy was invited by this guy, Georgi Gladyshev. Everybody studies Zengel and Boyle's. You've all probably seen his the cartoon about every time you do something in this house, you increase the entropy. Now, here's Zengel and Boyle's. This is almost childish. Zengel doesn't go into this deeper, but if you look at the history of thermodynamic textbooks to start employing thermodynamics, there's about 8. And there's 500 people that have written on how entropy, free energy, enthalpy, temperature apply to humanities, which go beyond a simple cartoon example. So the first book was about love and religious science debate right here. This guy. The second book is Religion, Science, Prove the Existence of God. But now this book here, he's one of the members of the Encyclopedia. Benjamin Kyle is a chemical engineer. He published all of this as an attached CD-ROM to his 1999 Chemical and Process Thermodynamics. You can, all these guys stick, especially Henry Adams right here, he's one of the biggest fingers. So you can go through all of these, you can see how economics applies in literature, in art, philosophy, psychology. It's difficult. There's not one thermodynamics on all these. And here's an example. Here's a recent one. This one cites my 2005 advanced human thermodynamics, which is another central hub page. This is cited in here. The formula cited in here. This one touches on economic. You can see it's starting to increase. And also in chemistry textbook at the bottom. Right, so Zengel boils. Here's one that's pretty cool. He talks about thermodynamics applies for friction. How many people know that in 1858, Henry Carey talked about the social heat of friction, rubbing together human molecules, again, that's human molecular theory. And what today we get people have done cartoons, but we don't know that there's actually a 3-volume textbook that's already written on this. And there's also the mechanistic school at Harvard, which is, you can read a whole 60-page chapter on that. Another thing that's pretty cool, John, you read the Soluble Boyle, 1 sense, maybe 30. Low, he says a high entropy army is less powerful than a low entropy army, but he doesn't go into that detail. This guy right here, John Boyd, was an aviator fighter in the Korean War, and he was wondering why the Korean planes were faster and quicker, the MiG-28s, than the F-16s were bigger and slower, but Americans have better fighting skills. So after we got back, we had a 10-to-1 kill ratio. The 3 and more over the MIGs, which are quicker. He didn't understand that if they're quicker and smaller and more maneuverable, they should have a higher fuel ratio. So he went back to college and got a degree in industrial engineering, and wanted to understand. He started studying thermodynamics and wanted to understand how you would understand it in terms of thermodynamics. And he ended up going on and consulting Pentagon over 1,500 times. And the first Gulf War was actually based on his thermodynamic formulated theory. So this is pretty cool. He used thermodynamics to successfully architect the invasion of the Gulf War.
I'm sure you have many things to say and maybe some concluding remarks since the time is winding down.
Yeah. I guess it's 10:45. Again, it's difficult for me to get through all lectures, but you can go back and skip really all the online and go back to the main lecture page. How about, here's the table of contents.
I guess it's all posted on the web and linked to our class assignments.
So far we're at lecture part 23. Ideally I wanted to go through all of it, but I guess it's not enough time. But you can go back online. Hopefully the video will be online by the end of the day. You can compare how mechanical engineers over historically have gone about this approach compared to chemical engineers. And also a good idea is everyone in the class put this homework problem page here. Try to solve one homework problem. There's clues next to each homework problem and turn it in Professor Kostic as extra credit. What sort of questions do we have? Anybody have a question?
Just let me make a little transitional conclusion. If you are confused, don't worry. I'm confused also. And as I told you, first step in learning is confusion. Yeah. And by the time you resolve confusion, then you learn. And this is a little outside the mechanical engineering thermodynamics. It's extension to chemistry, and we do not really cover it in the first course. And then in biology and in sociology and philosophy. And in my class, my students knows what is energy. Anybody likes to say, what's my definition of energy? It is everything. And then for every process, you must have exchange of energy. Therefore, thermodynamics runs through all processes, not simple mechanical, but more complex chemistry and biology and sociology, and our brain thinking is involved in some process which is governed by thermodynamics not that easily. So Libb was trying to expand it as far as it could go.
Just to make a connection between your graduate professor was Mansouri, right?
Right.
Okay, just to connect us all together here, Mansouri's teacher was Iranian mechanical engineer Magnus Arkin, who wrote the first book on thermodynamics and humanities. So we had a good connection here, but the problem here, he taught Mansouri taught Professor Kostic, but along the way in teaching these things that
but I was in so-called energy engineering department, which later on split in chemical and mechanical, and Mansouri went to chemical, and now he's focused on biology. So he's spreading all the way. Any questions? Yeah. So basically, thank you for the very interesting and a little unusual presentation. And now you could ask anything you want. Speaker is there to answer.
Questions? Anybody?
Just make sure I understand everything. Your entire lecture is basically relating social interactions, humans, to thermodynamics, right? So make sure I understand.
Yeah, I'll give you the short one sentence. The first and second law of thermodynamics govern every system in the universe, including social systems. So that's what we're talking about here. So how that translates is energy is conserved. Entropy, instead of talking about entropy as in Cengel as disorder, the original name for entropy was transformation content. And every day the society is heated, we're about to globe with here. Every time the day is heated, you've got a Carnot system heating. So you get when the sun shines, the Earth turns towards the sun shines on it, you get a social expansion. So that's entropy increase. Then when it comes down, this is contact with the hot body of the Carnot engine. When you go back here, you've got decrease in entropy, contraction volume. And it's put in contact with the cold body, the dark night sky. So the change in between that one cycle, between the social system going up to its maximum volume, the example of which is when it's warm, summertime, everybody's out partying, having a good time. When it's 0 degrees, 10 o'clock at night, everybody's in their homes contracted. It's what's called Boerhaave. And the entropy, instead of the change in entropy, is the original name for it is called transformation content, which means that the system is not in its original structure, and the difference in configuration is the entropy increase. So that's what we're talking about here. Is that cover that a little bit? So, no question?
Well, wouldn't that have to do with your comfort? It's easier to be in the daylight. You can see you don't need light, right?
Mm-hmm.
I mean, you don't want to be in the cold because it's uncomfortable.
Yeah, that's exactly the point. But then again, what you want to do is you want to scale this all the way down here. You have to think about it in terms of here's all the textbooks where we're starting to see these are the 6 textbooks where you have to think of yourself as a molecule. All 6 of these, top 3 are the Stirner-Elster calculation of the molecule. Bottom 3 are all my formulas. When you think of yourself as a molecule, you have to scale yourself down into the smallest atoms. You have to ask that same question again. If you heat a hydrogen atom, talk about does it feel comfortable so it expands? You heat a water molecule so it doesn't feel uncomfortable. It goes inside and returns to the gas phase. Let me just see if I can find any here. Here's a nice poll. 66% of people internet read their molecule. I can't find it right now, but somewhere under your Google molecular evolution table, you can look at formulas, all human all the way down to past the bacteria down the thing, so you can. Again, it's a conflict between the belief system and what you learn in physical thermodynamics, so you have to kind of grapple with that one. Probably didn't explain it good enough. Another question? Well, thanks for everybody for coming. I appreciate it. So,
I assume you give the book away, right?
yeah, everybody, these books are for you. I brought them for you. Take them with.
Yeah, so if somebody didn't get the book, I think you could get the book.
You can use this. Some people have went on. Jeff Tuhan did his PhD dissertation. He read about my second book, The Human Molecule, which is the history of human molecules. And he was a civil engineer. He went to Germany and completed his ecological engineering degree on fish systems. Around power plants, every time the city uses a lot of power, the power plant consumes more energy, and that affects the waterways by what's called hydropeaking, which affects the flow of the river. So we can see the idea that you can take all of these equations, the theory of human is molecule, and fish is also a molecule. So we wrote a whole dissertation on how you can apply thermodynamics to fish to find this molecule reactive molecular system. And of course, power plants, they fund these projects because they have to give money back to the community to keep the ecosystem right. So you can use the book for wherever your imagination takes you. Okay, yeah, real quick, this is a quick ball and ring experiment here. So you want to think about this the same way, think about this as the surface of the Earth.
We have fire extinguishers somewhere around, right?
If I did this, I'm on Straight's place. But if you heat the ball, in the 17th century they had what's called the fluid theory of heat, or caloric. Before entropy was called caloric, which was an indivisible particle that couldn't be destroyed. Before that it was terrapinguous. Before that was what's called the matter theory of heat. And they used to think that heat had mass. They couldn't figure out how to do this experiment. So originally the ball of heat goes through, if you heat it for 30 seconds, this is called the ball and ring experiment. And Leiden University, the original Thermodynamics University was the École Polytechnique in France. And that's where Sadi Carnot wrote his on a motor power fire that founded from there. Before that, Leiden University did all these heat experiments. This is what's called Boerhaave's law. If you heat a body, it will increase in volume. So we heat for 30 seconds. It doesn't go through the ring. Then we have entropy increase in the metal. Now, just like the surface of the thing going on here, society expands in volume just like this. And you can quantify this. Now, if I cool it, just like a Carnot engine being put in contact with cool water, we have volume contraction, and the ring goes through. So, and you have entropy change in this process. Now, when you, instead of thinking about entropy as messy room, what you want to understand that different entropy increase is called transformation content, and it's based on what's called the Euler-reciprocity relationship, which you can look online. And I go back to Leonard Euler's most prolific mathematician, and that's where you want to get your, you want to understand resistance. Anybody have a question or anything? Thanks for pointing it out. I almost missed it. Yeah. Last time I came lecturing, I forgot to go.
Did you do all experiments with all your gadgets?
Yeah. I've got mine.
So thermodynamics goes from a real atomic microscale all the way to cosmology.
Yeah, and even after a lecture, Professor Kostic and I were going to talk about thermal energy, which is a typical term. Entropy and energy apply to everything we do in society, but the explanation of this is a little difficult. That's what. But if you go online here, place you want to go here. If
you have to run for your next schedule, don't be shy. Those who like to stay, you could stay.
If you want to find more information about this, just go to HT Finders. This is the page of 500 people who have published on thermodynamics. You can scroll down here. You can go through everybody. There's James Maxwell, Henry Adams, Sigmund Freud. Here's pretty cool. This is Leon Garcia. I still haven't been able to get his stuff translated. Here's the guy who taught the social mechanics school, and I don't even have a photo of him. It's really irritating. He taught social mechanics at the University of Geneva, the same stuff I'm teaching right now, over 100 years ago. He mixed it up with the Lagrangian formulation, and he explains politics, economics, sociology, beauty, morality, using the Clausius inequality, which is really cool. But again, the subject is so underground that his book, the essay on social mechanics, is still in Italian. There's no English copy of it. Translated a few pages of it. So but go to this page, HT Pioneers. It took me 10 years of research to write this page. And I have the biggest thermodynamics book collection in the world right now. I have 365 thermodynamics books. So anyways, you can scroll down here. Here, this guy, Maurice applied thermodynamics to law. That's the word sociology.
So there is more than mechanical engineering thermodynamics.
Okay, don't scroll here. Talliard is
much more.
Religion.
We are doing obvious, simple things. Ideal gases and water.
This is where we are up to 2000 right here.